Thank you very much. I hope you have some concentration left. I'm going to show some code, so brace yourself. It's not going to be very complex, but hopefully it would make sense. Just a sec. So my name is Vlad. I'm Vlad Sizov. I'm a senior consultant at Adaptive. We're a financial services software consultancy. We've grown rapidly within a few years, and we have more than 110 consultants globally. We have offices in Barcelona, Montreal, London, and opening this year an office in New York. So today I'm going to talk about a specific topic. Basically, I'm going to talk directly to developers. I'm going to show you how web application grew up and demonstrate one specific challenge that its growth brought to us. So in the old times, we were relying on the simple JavaScript applications. They were just basically scripts that were relying on globals. They were simple scripts. There was no need to have a complex scalable code spread across multiple modules. Basically, JavaScript was the thin icing on the server-side cake. And today, it's no longer the case. App complexity has grown exponentially. We write large-scale enterprise application with JavaScript and TypeScript. Applications are spread across tens and hundreds of modules. We have non-trivial dependencies between components in your modules, and this is a complex problem to solve, to manage dependencies between your code, between your modules. So this power of writing really complex application comes with a responsibility to control the growth of the complexity of the code and control interdependency between your modules. So your application can consist of multiple models, services, controllers. I'm not talking about specific framework, just in general, the main plain parts of your application. And these components would need to know about each other. There should be a strategy how you manage these components in a scalable and controlled way. Today, I'm not going to come up with anything revolutionary. I would just break down the problem and show you a known pattern to solve it, and hopefully this would make your life easier. So previously, how we would bring dependency into our code. We would use the simplest way would be to use AMD or E6 module imports to bring it to the code. And this is a simple example. Let's imagine we have an application service that connects to the server side. We have a model that holds application state. What we want to do, we want to monitor the state of the service and record it in the state of your application. If you follow the separation of concern principle, you would write a third-party component, let's call it monitor, listen for events in the service, and record it to the application model. So very easy, and naturally, straightforward, you would write it with AMD or E6 module imports. The problem with this code is that your component is not pure. You're depending on the side effects. You're bringing the concrete implementation of the service and app model. These are instances that will be, in this case, would be global across all of your application. So having a singleton across your application makes your code quite hard to test. And also, you are importing concrete instances of the service. You're breaking one of the core principles of programming to the interface, not to the implementation. So what would be the natural solution? Okay, I'm going to pass my dependencies to the monitor. So the next one would be, let's use dependency injection. That sounds scary, but let's inject our dependencies into the monitor. Service and app model instances are now coming into our monitor. Monitor becomes a pure function, great. It's very easy to test. You can mock service, you can mock application model, very easy to work. Inject different implementations of service, works great. But now, who passes these dependencies to it? There would be somewhere in your application a code called owner of the monitor. That owner would create an instance of the monitor and send this service and app model instances to it. So let me show you graphically how this looks like. A monitor there on the bottom right, one service and app model. We need to pass it somehow. Probably the monitor owner would bring it. So let's create the instances in service, instances of service and app model in the monitor owner. if you do that, you basically brought the problem a bit higher. Great, your monitor is a pure function, testable, but now as soon as you import a specific, concrete class of service in your monitor owner, this will become now complex to test because you are, again, bringing concrete class or factory that you would need somehow to mock if you're writing tests. Also imagine that someone else in your application wants this instance of the service. This monitor owner would have to pass it somehow to it. So it becomes harder to maintain. And you would naturally think, okay, I'm going to push it higher up. So now you pushed it higher up. Your monitor owner, your monitor are pure functions, brilliantly working, and now you have root class that creates everything in your application and knows about everyone. So if you close this, works great. If you open this, you end up with this. So this is you trying to find out a way to pass instance A into instance B through the instance C. I witnessed in my life a God class like that of 6,500 lines of code, which was unmaintainable, untestable, and basically like there's no way you can do anything with it. So this problem has been solved before in other technologies for years and years. It's solved in a way in the pattern known as IOC container, inversion of control container. So basically, someone magically creates dependencies for you and injects them to your code. Your code becomes testable. You are basically, you remove the need of creating dependencies to somewhere else. The only thing that you can do, you describe how you want these dependencies to be passed to you. There are a lot of details. I'm not going to stop on them. But I would like to point out that this pattern is still feels a bit new to JavaScript community, even though there are quite a lot of frameworks, Angular 2 and others that are using it. But sometimes people think there's no place for this pattern in the JavaScript, or sometimes people just don't know about it. You can implement this pattern in ES 2015 quite simply. Angular 1 uses it. There are separate implementations for it. But nowadays, this can be implemented in a more declarative way in a new technologies, in a new stack. So this is an example how it would look like nowadays. It is based on the decorators. This is a proposal that is now in stage 2 of TC 39. Decorator is the way to add metadata to your component. So people are familiar with annotations. Basically, it is almost the same thing. By doing that, you are describing exactly what your class, what that inversion of control container need to inject to your class. You just described the way how it has to be configured. You run application and magically goes into your instance. There are multiple implementation of the IOC containers with the decorator pattern based on decorator. It's Angular 2, Aurelia I mentioned today, and there are multiple others. It works. In adaptive, we're using TypeScript IOC container in production enterprise applications. It simplifies dramatically the way how we write code. And I would encourage you to, if you're not doing that, at least research it and see how it would help you. There are much more features in inversion of control container pattern that you might be interested in. So there's nested context when you have multiple layers of your context, defining dependencies on global side, on global space. You have nested context, which read dependencies from parent context. There's a context discovery where you would create an instance of your UI component and it will find the closest context, resolve the dependency, and basically work with it. So this is a short intro to the inversion of control container pattern. You don't have to use it in every project. There's no sense to do it, but have it in your tool belt. It's extremely useful in the large-scale applications. It would remove quite a lot of headache, and just be aware of it and use it when needed. Hopefully, you will see how much cleaner your code becomes with it. So if you have any questions, find me after the talk. I would be happy to share our experience. Thank you.